All right, panel discussion on Perl and Scientific Programming. I hope I spelled it right. About 2 years ago, I was at Madison that I met Joel Berger, who was just up there, and talked about science with a couple other people. And he had a thing called Perl for Science. And then shortly after that, I thought, oh, let's start something like a discussion group. And I kind of stole the logo for the, if you've seen the quantified self logo, I kind of use that for the quantified onion logo. So. And in the panel is we have Jay Hanna, LAPS BioPerl user and Lord of Fire Emeritus. Over there is Walt Mankowski, postdoctoral researcher at the Bioimage lab at Drexel. And Dana Jacobson, who was roped into this panel on the way from the airport to here. He's a senior software engineer at RentTrack. And let's quit this out and you can actually see Joel Berger, you know.
Hi, Joel.
It's Joel. Hey.
Hi, Joel.
Live from Chicago.
Live from and basically, I have some prepared questions I'm going to ask everybody, and we'll get their thoughts. Here we go. First question. I guess we'll ask everybody, in what way have you used Perl for scientific programming? We'll start with you, Jay.
Start with me? Okay.
Yeah.
Hi, yeah, my name is Jay Hanna, and so now it's been about 4 or 5 years ago that I was minding my own business, working for a hotel company, doing data crunching, database data crunching, and a guy wandered into one of my Omaha Perlmonger meetings in Omaha, Nebraska, where I live, and he said, oh, hey, I'm a molecular biologist. Can you help me crunch these DNA sequences? And I said, you're a what, and can I help you with what now? Because I'd forgotten everything that was taught in high school, if anything was taught in high school way back then, about genetic sequencing and how to modify genetic sequences. So I worked part-time for 3-4 years at the University of Nebraska Medical Center in their genetic sequence analysis facility, basically doing data crunching. That was my claim to fame, I guess.
Well, Dana.
Hi, I'm Dana Jacobson. In 1991, I was working at the EPA research labs in Corvallis, and we started using this tool called Perl. It was really good for a lot of things. And I ended up using it for bibliography processing for all the scientists who had tens of thousands of articles in their own bibliography databases, and they're collaborating on papers, but they all used different databases. And Perl, as we all know, is good at text processing and doing all those transfers. I lately have been using Perl for math libraries, mainly number theory.
Okay, and again, I'm Walt Mankowski again, and I just finished up a PhD in computer science at Drexel about 2 years ago. I use Perl a lot in the course of my research. I mean, did probably most of my programming in Perl. Although mostly what I was doing, I was running simple experiments that generated a lot of numbers. I would store them in a SQLite database, and then I would pull them out and make graphs out of them. So kind of made some glue to talk to GNU plot and make graphs of what I was doing. Excuse me, we don't use Perl a lot. I mean, we're mostly MATLAB and C++ in my lab now, although there are some uses for Perl even there. The movies I was showing you during my talk this morning, the file, so we get them as a number of frames. There might be like 2,000 frames, and they all have very long and complicated file names with some increasing numbers. So we try to normalize those, and so I've written some little Perl scripts to just munge the file names and get them into our format. But yeah, so that's kind of like what we're using Perl for now. And as I said in my talk this morning, I'm not sure how well it would really map to what we're doing in my lab currently as far as the day-to-day number crunching.
You're my foil, Walt. You're my foil.
Right, so I'm the foil. I'm the foil. Right, that's my job.
Yep. And then Joel, and I forgot to mention, Joel, he gave the keynote at YAPC Brazil last year, correct?
Yes, 2013.
Okay. And how did you use Perl in scientific programming?
Well, beyond just the regular number crunching, why don't I talk you just, I used it through my PhD research a lot. I had 2 different sort of phases of using it. My research was about ultra-fast electron microscopes. So basically video rate electron microscopes, except the the video rate fast enough to actually see things like reactions happening. So of course that has to go very fast. And so we took lots of pictures, and I had to extract lots of information from them, and I used PDL for that. But then we had to start modeling the propagation of the electron pulses in the column, and that's where Perl really started to shine for me. And I wrote quite a massive simulation that models propagation of short electron pulses, and actually that's on CPAN, so you can see it. And maybe I'll talk a little bit more about it later, but it became a very useful simulation, and I hope the industry will start using it as a primary tool.
Cool. All right, well, say second question. Do you think Perl is just a glue language, much like many of you have done, or can we actually make it a primary language for science? Anybody want to jump at that?
Well, so the most complicated thing I was probably working on, it worked great as a primary language for me, just in, so we were, I've forgotten a lot of the lingo, but we were looking at all of these variations, possible variations and mutations, and trying to find target sequences that would fit this pattern, right, that the scientists were looking for. And so we used a 1,200 node supercomputer, if that's still super anymore by today's standards. And all of that was in Perl, and the startup time on Perl, of course, is long, but the runtime of this particular thing, the way that I segmented out the workload, was long, so it didn't matter that the startup time was long, and it worked out great for a primary language for what I did. So that's one scenario of, yes, it can be a primary language.
Okay, so if there's one thing I learned in grad school is that the answer to questions like that is almost always it depends.
Right.
So I mean it depends on what you're doing. I mean PDL, you could use PDL. It depends. If you're doing number crunching stuff, you could use PDL for that, or you might, for the reasons I said this morning, want to be using maybe Python more than that. If you're in the computer science department and you're doing graph theory stuff, there's graph.pm, which is awesome. And I mean, for a lot of things where you really want something that's kind of flexible and you can just churn through code and write something really fast, then more so than just sort of raw number crunching. And even the reason I was able to do what I was doing was that there was a tiny little bit of MATLAB code that I did have glue to try to tie it into that, but all the rest of it, the sort of managing the data and storing in a database and pulling it back out, is what I did in Perl. And I did some of the kind of simpler number crunching stuff in Perl, like edit distance code and stuff like that. Was fine for Perl.
Okay. Thoughts, Joel? Oh, can't hear you. What? Is it muted? Okay.
Yes, I'm muted.
Oh, okay.
I found it.
So you think it'd be primary?
Switch you to
the what?
My desktop, and hopefully you can see this now.
Okay.
Of course, it's recursive right now.
Cool.
So this was can you see my screen here? Should I make it bigger?
Maybe I'll make it bigger. Yeah. That's pretty good. Is that good? Yeah, that's better, yeah.
So, I mean, if you want to go see this example, it's physics : UEM column on CPAN. And I bring that up because I thought it was very important to write my simulation in a way that people could actually reuse my code. And so my simulation really used lots of modern things, Moo and Type Tiny and all kinds of other fun things, such that I can define my experimental setup as just a laser object, an accelerator object, the vacuum column object, magnetic lenses, etc., and just compose them together and run propagate, and then plot out the results. And this, I can just show you, because I just tried it to make sure it actually ran. Does indeed, where'd it go? Plot out the track of the electrons as they propagate through the column. And I won't explain what this is, but as you can see, it's useful results. And this entire simulation is written in Perl. but that's sort of, though it's an implementation detail, Perl was useful to make this tool because it used lots of closures and passing of complex data sets and such. So I really think that Perl is better than just a glue language. I think it works quite well as a scientific language and a language that you can build a nice user-facing API to build generic simulations for your users. It doesn't just have to be cobbled together one-off scripts.
Cool. All right. And see, next question. PDL, the Perl data language, is kind of the, like I said, the canonical language, the science module, along with BioPerl. I don't know of many other big modules that are as science focused as those two. Do you guys know of any other? Could recommend any other modules outside of that?
So for math,
my Perl for Science has a list.
Oh.
Though a lot of them do have to do with PDL. I'm sorry, with BioPerl. If I can pull up Perl for Science quickly here. I'm probably not screen sharing anymore, am I?
No. I could probably go to it, Joel.
No.
Yeah.
Okay, yeah, if you could.
Come on.
If people are interested, there is. Oh.
Yay.
And maybe I should mention these things more often because
That's under software, right? Yeah. And the software lists all the.
anytime I would mention this before, people would contact me with more modules they wanted added to this list of plotting and otherwise useful things. So maybe I should. Here, Demeter was the one I was trying to think of. But yeah, there's lots of useful things.
Yeah. I was like when I was putting the slide, it's like, oh, is this Perl 4 for science? No, but no, it's like, wow, no. But yeah, this is actually, I didn't kind of mention it too much. I guess this is Joel's thing to kind of be an aggregation, like the website for Perl and Science.
I mean, a couple of other things that I used in the course of doing my research. One was graph.pm, which I think Jarkko Jättimäki wrote a long time ago, which is really useful, very easy to use. And I use set : scalar for just do set operations, unions, and intersections and things like that. Some matrix, is it called matrix : real to do matrix multiplication?
Maybe? I can't remember, yeah.
Which I have no idea what the performance of it is or anything, but that wasn't really an important thing for what I was doing. It was I used to use that for a graphics class I took. We could write the code in any language we wanted to, and for some reason I decided to do it in Perl, which was ended up being a mistake more because just towards the end of the class we were doing more complicated things. It was taking a long time to run. But certainly if you just have some matrices that are not really big and you just want to multiply them together, it worked fine. And you don't have to install a whole bunch of other stuff for PDL. It just kind of it works pretty easily.
Cool.
So.
Sure. All right, let's see. What was my next question? I kind of mentioned this a little bit in Walt's talk today. I think for NumPy, SciPy, Python in general, the killer app for that community is Matplotlib. It took MATLAB's awesome plotting abilities and mapped it straight into Python. Does Perl, do you think, have anything similar? I don't think Perl has anything quite as good as Matplotlib. I know Dave Mertens, with his Apprima stuff, was trying to do something like that. But what are your guys' thoughts on it?
GFAD was doing some kind of fancy plotting library.
Like Chart Clicker?
I don't remember the name of it. It might be Chart Clicker. Yeah, it did. Yeah, so I remember GFAD gave a talk a few YAPCs ago about a really nice graphing, like making plots and graphs.
Right.
I unfortunately don't remember the name of it. And that's not really a scientific thing, more than just any kind of graph. Any kind of data could be graphed using
Right,
it.
I mean, because I think, like I was talking with you and Dana, it's like you got to get from data, after you analyze it, now you have your pile of nice analyzed info, you got to present it in such a way that everybody else can understand in a quick, easy way. And it's, maybe Joel, since he's much closer, like say Apprima and stuff like that in terms of plotting stuff, but once you got to have that nice pretty picture for people to really understand what you do. Yes?
Is this to the exclusion of PDL's graphic capability?
Yeah, absolutely, you have to.
I've never really explored them, but I know they exist.
I don't
Is
know.
someone talking?
There's tons of pictures of it.
Yeah. So what's your thoughts, Joel? I mean, you're much closer to Piddle than I am, so.
Yeah, so the problem with PDL's plotting capabilities has always been that there were too many, and thus they were all under love. I think David has done really spectacular work with Prima. The problem still is, exporting plots. And so for my thesis, though I use Prima for all my sort of internal development, I ended up throwing a lot of the data into CSV files and then using GNU plot to plot them.
Good old GNU plot.
I would love to get that fixed, but I just don't know what the great solution is. I think one thing I've seen out of the PDL world just in the last few days is someone's trying to use the IPython shell and hook PDL up to it,
Okay.
which would hopefully give us a nicer REPL than what we've got so far. It is a frustrating lack of support there. And not for the want of trying. It just turns out it's really hard to make a generic plotting bindings.
So in 2010, I was doing some CFD work, and I found, at least at that time, I could not find anything that compared to Python's matplotlib. So I ended up with this horrible, or Unixy, depending on which way you look at it, CUDA to C to Perl to C to Python to give people pretty output, and everybody was happy with the end result, but I felt a little dirty using all of those different tools together.
So I also, like you did, use GNU plot, but I kind of hacked something up where I opened up a pipe to it and I basically wrote a little GNU plot routine inside my Perl code and then just executed it. And it seems to me that you could, you could do pretty much exactly the same thing and that's how I was calling the MATLAB stuff as well. And it seems that you could run matplotlib just as easily, or kind of formalize it. I mean, it was ugly, but it worked, and it seemed to be.
The GNU plot gets in the way of, if you want to be object-oriented, the GNU plot isn't.
Right.
But I wanted to get graphs more than I wanted it to be object-oriented. There is, I believe it. I mean, but there is a module. I don't know how old it is.
There's a GNU plot
There's a
module
GNU plot
to interface with,
module,
yeah.
but the reason I didn't use it,
Yeah, you
the
just go
reason
right
I didn't
directly
use
to
it
it,
is
yeah.
I already knew how to use GNU plot, and I didn't want to have to learn, for everything I wanted to do, I would have had to learn how to do it within the module rather than just doing it myself. And
Right.
The other thing, though, is, GNU plot sort of doesn't look very professional.
Yeah, it's the plots it makes aren't as clean and pretty.
yeah, but
But it depends on where you're publishing them. That's fine.
how many people ever read your dissertation anyway, right? Yeah. I mean, I think my advisor may have read it.
Sure. Yes.
Go to the state of the project, but Octave is supposed to be a MATLAB clone.
Right.
There may be some Perl interfaces to it.
Maybe.
I remember it's been a while since I've done it, like over a decade, but when I was writing batch processes to generate plots on a product, we were interfacing directly with MATLAB.
Yeah.
It was really gross because we had to create an X11 session and then export the image from that.
Yeah, I think a lot of Perl people actually does what everybody's done. We find something external to Perl and use. I have a buddy at work, at the university. He uses R for his plotting. So we find something external and run it. It's whether or not we can find bindings and can tolerate the pain.
A lot of hacks.
Yeah, and it works. Cool.
I should say the Corey stuff did look better than that, and
Corey stuff, the chart clicker stuff.
the chart
looks
clicker
awesome.
stuff looked awesome, and I don't know why I've never used it. I don't know. I just had something that worked.
Yeah.
So
Yeah, the hard part is like when he's getting the external dependencies like Cairo stuff working well enough for Cairo to work, or for chart clicker to work. All right.
And before we move on, I want to say one more thing.
Sure, sure.
I feel like I did sell. There was another module written for binding PDL to GNU plot, and I didn't mention that, and I should have. And it does quite well too. So.
Yep.
But again, you need to have GNU plot.
Yep. Cool. All right. That's my next question. And I kind of mentioned this before in Walt's talk. Is Python XY is this nice distro it's for Windows. I think they might have a Linux distro, but it kind of brings everything you need to bring to beat up MATLAB. But that's the canonical thing I use, because like that's what everybody in academia uses, is MATLAB. But I don't know if there's anything we can compare against, or should we compare against? Is this that platonic ideal of application for scientific programming, or not?
So I'd say in some of the work I did, it wasn't MATLAB so much as lots of specialized tools that did what they did really well. And what I saw, to me, one of the killer apps of Python is they make it really, really easy to integrate Python into your application. So yeah, Perl just doesn't do that as easily, or we don't document how to do that easily. Because these applications are very good at what they do. We used Paraview. Paraview is great at visualizing lots and lots of data. I don't want to do that in Perl. But what they don't have is a scripting language to make it really easy to do the things you want to do in a virtualization environment. And so it was very easy for them to plug in Python. Now they don't have to have a scripting language. If you know Python, you can do all kinds of stuff. So I think if we spent more time in Perl doing that, and I think I just volunteered.
I won't say it. I won't say it.
So I was going to say, the external tool that we would be interested in, the people that I know have also gone this MATLAB to Python path, is OpenCV. It's a computer vision, open source computer vision package. And if you're using MATLAB, there's an image processing toolkit that we use all the time. So you don't have to write the stuff to find the edges on the images, or to do thresholding or all this other stuff, because it's already written, and that comes with OpenCV. And there is an OpenCV module in Perl. I don't know how much love it's gotten, but again, it's not just that, but I'd want it to be integrated with other stuff as well that was very hard to the documentation just looked like we took all the OpenCV
We just
calls,
dump the API bindings in. Here we go. That's all you get. Yeah.
Whereas if you do it in Python, you get NumPy objects out of it that you can use with other stuff. So.
Yeah, like I said, my comparison, my talk I gave at Pittsburgh Perl Workshop, like 3 years or whatever it was, is that I think Perl and Python have a deep bench of modules that can do stuff, because MATLAB does also have these toolboxes. They have a deep bench of specialized toolboxes that, like say, that they do the OpenCV-like stuff. The hard part is, like say, making that nice, neat, integrated package. So I guess we're saying MATLAB is the beast to compare against.
Right, but you kind of reach a point where you outgrow it, especially if you're like if you're not like an engineer, but you're programmers. Once it gets above a certain size, you want to be able to modularize things more and do kind of software engineering.
And quickly outgrow MATLAB.
You quickly outgrow MATLAB for that. MATLAB. I had heard that people outgrow it for performance reasons, and I think they've gotten a lot better at that. Another thing that MATLAB does is a lot of their internal tools will automatically run things in parallel. So you don't have to do anything, right? If you're running something that's going to take a long time on a big image, it'll spawn it on all the cores that you have to make it run faster.
Sure.
Which again, Perl's not going to do that. Perl 5 is not going to do that.
Any thoughts, Joel?
Well. No,
I want to go on my panel people here.
In the context of like bundling in dependencies and things, I think we could probably do something like that, something interesting that would bundle in, I don't know, all of GNU plot and some image manipulating libraries and some of those things. But it's all a risk return reward kind of calculation. Of course, we would love to do that, but it's going to take a ton of effort, and I don't know what other people need. I don't know even where to start, really. I think what a lot of people like is the shiny stuff, and I think trying to build a nice shiny in-browser REPL is probably more significant than bundling all the dependencies.
Okay. That
Perl
actually
has.
Yeah. Is it to do what? Docker. Okay, yeah.
The stackable kind of thing, because you can have dependency of one doc on another doc and generate a stack. What might be neat is to find out what are the dependencies that people have for GNU plotting stuff stack these things. You could stack GNU plot on top of a copy of Perl that had the GNU plot stuff with it. That might be a good way to do it, is to have the Docker library. You could check out a thing that would just pull all the stuff under it pre-compile. Most of the times when you think about this, the pain is making sure that someone's got 5 modules pre-installed and give you the module dependency hell. We came up with a couple of these Docker blocks, we're going to call them, that had a collection of things people used together. That might be a really good way to ship a unit of stuff out without it getting into building every module on the planet.
Sure. Cool. Anything else for that question, I guess? All right.
I would definitely second Docker. That's a great idea.
Okay. All right. I've always been. This is something I've been thinking about since I work at Purdue University, and we have big clusters that I don't have to maintain. Thank God. Parallel computing is big, right? I mean, it's because we got these cheap processors now. We can just do all this crazy stuff. And like I was talking to Dana, and it's like I heard about this like maybe literally a month ago. NVIDIA has a new basically system on a chip basically called Jetson, and for $200 you get a 192 GPU core machine with like a little ARM chip to kind of get you into Linux for $200. And at max load it consumes like 10 watts. And I think I read that Volvo is using this for their autopiloted car to handle their computer vision processing. I mean, parallel computing's needed is, I mean, and like I say, we looked at the thing, it's like, what are our options for parallel computing in Perl? Or is it just, like say, a glue language that gets you into that system?
Yeah, for me it was always breaking up the problem space in Perl and then handing it off to 1,200 nodes that would do the job. Mm-hmm. So what is that called? Trivial or embarrassingly trivial parallelism. Yeah, so
yeah.
For me, Perl was a way to get it there, and it worked great to get it there. And then once it came back, I only really used BioPerl. That was my thing. Uh-huh. And in BioPerl, it does so many of the sequence manipulation things for you out of the box that was really happy with getting the results out of that. So as far as sophisticated parallelism goes, I'm probably not the guy to talk to.
I know, Dana, this is why you're here. Partly.
We did lots, and when I was doing CFD work, we did a lot of that, but we did not run Perl on the cores, certainly.
Right.
So it really was just glue and post-processing. But I think taking a hint from NumPy and some of these others is if we could have, and PDL certainly could do this, of you take a basic operation, a matrix multiply, and you have it done for you. And so now you write Perl, but it can go ahead and use all those cores for you.
So we do a lot of CUDA work in our lab, but it's all C and C++, coming from Windows. So I didn't even know you could do CUDA from Perl. Although I also like the idea a lot of like maybe even if it's hard to do threading from Perl 5 right now, that like it would be awesome if some commands which seem to be pretty threadable, I don't know, like if you have a chain of maps and greps, it seems like those sorts of things might be parallelizable, or something like if you ever use OpenMP where you have a for loop and you know that it's a big thing and you want to you can very easily parallelize it, and just with some compiler directives you can do that, and something like that in Perl would be awesome as well. But no, I never used CUDA. Actually, I've never even programmed CUDA myself, but we write it all in C++.
And I see Joel doing some research. Because like I say, yeah, there's you had MCE, many core engine.
So MCE is written by a guy named Mario Roy, who's very enthusiastic lately and has been trying to build this many core engine for Perl. I admit that by the time he was ready with it, I was basically done with what I needed for my research. But he was developing it with an eye towards PDL, and I don't know quite how far it goes, but it does this fork workers kind of architecture and is supposed to be pretty useful for doing things like this. He said he has some examples in here for PDL if people are interested. And then it's really too bad that David isn't here because he has written bindings for CUDA that apparently work, and I know he just touched it lately.
Yep.
6 months ago. That's lately, I guess. He wrote a blog post about it on blogs.perl.org too. So I know there is some work towards CUDA. PDL itself does have some small amount of native autoparallelization, which is relatively new, and I haven't played with that yet either, but I know it exists.
Cool. I think a sub-part of that. Yeah, we were, what option are we? Okay. And I think this is my last question I've prepared is, I'm actually going to piggyback on this. Like, we have, Perl can't do everything, right? But there's also existing libraries out there, and I know I picked GSL just because I know Joel did some work on it, but it's also it's a base library available everywhere. And would it be sufficient just to have bindings to these good libraries? And also, in addition to this, I know Joel did work with Alien Base to make it easier to deal with these external dependencies, to make it easier to provide the system.
So I think that's really important, but I think something Walt talked about was, especially with NumPy, how everything is integrated together. And I love CPAN, but there are many ways to do it. And so if I have an array object and someone else has an array object and they don't really talk to each other, that makes it really hard to chain things together.
Yeah, and if I have an object and you have an object, maybe I used Moose and you used something else, and our objects can't even talk to each other. And
right. It's a blessing and a curse of CPAN, right?
Right. It's a blessing and curse of CPAN. I mean, having said that, I've used GSL. I mean, not from Perl, but I've used it from.
I mean,
C,
that's like GSL is it's everywhere. It's the
right. But I guess the question is, like, what are you going to be using GSL for, and what were you hoping to be doing with the output from it? I don't know. I've seen lots of, often when you take a big library like that or OpenCV, you can't really just take you can just put a Perl front end on it, but you really like it to be more Perlish and less C-ish to really be useful for it.
Right. So, any thoughts, Joel, on the whole library bindings and stuff? Since you've actually done this.
Well, yeah. So the reason I wrote my own GSL bindings, and I admit I haven't done all of them nearly, but anytime I would touch a certain GSL library, I would try to expose it where I could. The bindings that exist on CPAN, sort of the complete sets, are through math::GSL, which is done by Swig. Duke Leto wrote those. I mean, they're useful, but only as useful as making C bindings. And then PDL has a lot of GSL bindings too. So the question was, why did I build my own? Well, I made it really Perly, where you can pass it closures, and it uses just Perl native types to do manipulations. I think that's a useful thing. Of course, that's really manually intensive. You have to write all these bindings, but once you do, they're really well exposed. I thought, if people do find themselves using GSL, I'd love to see them work with me on making a nice binding for each particular function that you need. Yeah, I mean, there's a lot of stuff in GSL and similar libraries that you just really don't want to re-implement. And I think for that reason, binding to GSL and some of these other C libraries is seriously useful. I don't know what the state of Python GSL bindings is, but my guess is, if you're doing really hardcore numerical differential equation solving, you're probably using GSL to do it.
Cool.
That sounds like the kind of thing that the Perl Foundation would get a grant for someone to sit down and write really nice bindings.
Right.
Would it be worth stopping? What are the things, GSL is one of them, that would really be worth having top-notch Perly bindings, like not just
a bare C bindings, yeah.
And stick it up there. People don't want to. That's why they're using Perl. They don't want to see. libraries other things are there? That if we had them, that would be something really nice and shiny that people would use.
Well, I think also, I mean, I think after Walt's talked to Rennie a little bit, I mean, there's a step 0 here that I didn't really make a slide for it, but it is in the description, is how do we access strengths and mitigate weaknesses? And I think talking with Rennie, talking about how if we had some of this stuff in core just for like piddle stuff to make some of the data types or whatever, but it has to be a will, it has to be a community need for that, right? And it's not just identifying, oh, we need GSL and and Boost and Spice or whatever, or LAPAC or Blast or whatever. Sometimes you need to get stuff in the core to make it really Perly, let alone, I mean, I'm not sure if that's step 0 or just trying to get, do we want to,
Would be to ask, what are the things that if we had them, it would be really worth taking the time and the money and the effort to really have nice?
sure,
Then you stop and say, what would it take to get those? Is there an order in a sense? Is there maybe we don't need all of GSL the first day, maybe we need the 80-20.
Sure.
We need the 80% of it that really people need, identify that.
right,
But that sounds like a really worthwhile thing to sit down and do and ask, what would be willing, what's worth doing something like a grant and having it done for real?
right,
Can I point out that
Sure.
probably the most useful things would be bindings to credit libraries. I don't even know if that would be possible, but not,
it's outside my domain experience.
well, and that's why I mentioned it.
Right,
But not attempting to write Perl, but instead have a binding to a threaded library.
that talks really close to Linux kernel or something, right? Is that kind of theory,
Right. So say if something is threaded with threads or even OpenMP, it's a full joint model. I don't know if it would interfere with just a single Perl process that they call. That call would invoke some threaded action that works and gets back and returns back to the parent process. But we're talking about HPC and scientific computing. I don't think that you can really get much ground without providing that sort of.
okay.
So I'm going to take a slight tangent
Sure,
and
fine.
say,
We're in the free-form mode now,
Yeah.
Dina.
I think that's a great idea, but I would like to see us add some of the things Perl 5 already has to say these are really core ideas, so we can then look at Perl 6 and say, how would we interface all these to Perl 6? Because Perl 6 is still flexible enough that if there was something, we could at least get a chance to look at it.
When I've seen the Perl 6 parallelism tasks and things like that, it reminds me a lot more like how Mathematica is parallelized, because it has like parallel forms and things like that, where it distributes the work across the nodes. I don't know.
MATLAB has those as well.
Yeah,
Sorry, MATLAB has something called PAR4.
yeah.
Pari, the math.
We've got a lot of things that'll work well for embarrassingly parallelizable things. And just this year, we've got the more normal concurrency kind of things in that we've stolen from Go and such for promises and channels, and reactive programming stolen mostly from C#.
Sure.
And that's working out well now.
So-
Let me just say, I think a lot of focus is on distributed parallelism.
Uh-huh.
What I prefer to do, which is because of applications I'm generally interested in, is more shared memory type of threaded parallelism. And that's not to solve.
Yeah, fork is going to be too heavyweight for a lot of this stuff.
Sure, sure. And maybe that's something,
Maybe have data sharing.
yeah, and maybe that's something, because like I say, Joel has his Perl for Science, and I have the Quantified Onion discussion group. Maybe that's something, because the people that are involved in those projects haven't, I mean, Dave's moved on to just different stuff, Joel's moved, I mean, I've been kind of doing other things too. Maybe that's something good that the Quantified Onion group can do to try and identify these libraries and stuff, to try and say, hey, these are important. Maybe we can find someone that can write the bindings to make them Perly.
One of the design goals of Perl 6 was to, look at this mess of stuff that we have in Perl 5 and say, what is a decent default for most people?
Sure.
And pick those for the core language. But we want to do that for the libraries too.
Right.
What are the killer libraries that we should be talking to that most people will want to use?
Okay.
rather than just let a cow's flowers bloom.
Sure, sure.
And we're very interested.
Okay, so yeah, maybe I guess I volunteer myself to try and re-energize the quantified Indian group and start that thought to try and get. There are people doing science in Perl. Let's just find them and I guess grab them. Misty.
Would people want to spend more time discussing this than we have here today? Is this something people would actually spend time and effort to maybe work through to get to? Because I could probably get the money to have a 1 or 2 day conference in St. Louis and watch you sleep.
And I
Have a scientific computing in Perl conference and really sit down with people and drag everyone in one room so some guys can sit and try to deal with this.
Yeah. Well, I mean, I've thought about this for at least a year, is to have a science Perl workshop and kind of work. Okay, I mean, I haven't put the will towards to like, oh, I'm going to commit to be a workshop organizer, but yeah, I've thought about that.
I think, wasn't Brian Foy talking about that too?
A lot of people
Maybe, I don't know.
talking about it. I'm just saying, there are places I know in St. Louis where I could actually bloody well get it done.
Okay.
So I would be dumb enough to volunteer to do it, and I could probably get the money from the Perl Foundation.
Well, I mean,
try and get it done, but drag some people, and if people want to talk to them, I could probably con maybe Lincoln Stein into crawling down for something.
hey, yeah.
And
He.
some of this himself before.
Yeah, I think Heath.
Interesting, I think, to see.
I think Heath is, because I went to his, so he wanted to run a Perl workshop or whatever. He seems to be amenable, and the Perl Foundation seems amenable to try and really help people that want the help to organize workshops. And actually, this is one thing I've been thinking about for a year or two now. I just haven't put the will into it. But yeah, if we have a couple of us talking about it, maybe we can wrangle the people. St. Louis is a nice central location. It's close enough for me to drive.
It's fairly cheap to stay at. SLU has, and
Yep.
Wash U both have decent places to stay.
Yeah.
And it's not a bad place to party if you want to.
Yeah, I mean, there was.
We had
Yeah.
a 2-day workshop on what do we need to get so that people will use this.
I'd be happy with a one-day workshop.
Yeah, and, I know. So, right,
Yeah,
so
yeah.
I know one of the big sponsors of the SciPi conference is Susquehanna Investments, which is right outside of Philadelphia. They're a big brokerage firm, and I think he's one of the organizers of it. So the next time I see him, I'll talk to him and get an idea of like how they got this whole thing off the ground, and how did they even know that there were enough people doing cool science stuff that they could get a poster session together, that sort of stuff. SciPi in general, yeah.
They started in early 2000, and it was actually a commercial company.
It was. I'm sorry. It was a what?
One company
What was that?
would be willing to provide us some help with this. It's a small one based in St. Louis. You might have heard of it. Monsanto. Danforth Plant Science Center. They're heavy Perl users.
Nice.
So if we had a science in Perl workshop, there are several gene sequencing companies based out of Cofactor, like that, use Perl heavily.
Right.
So, I mean, a lot of them would be skewed towards life science, less than astrophysics.
But it doesn't matter. It's science and Perl. That's what we care about.
Certainly, if the initial topic were biological sciences with Perl, someone like Monsanto might be willing to sponsor a lot of that. And it's in their backyard. It's something they care about.
Do y'all not have to worry about the ethics of the companies that sponsor? I'm asking.
Well, I mean, yes and no, but I mean, we're there for Perl, and how far do we want to take our? I mean, it's.
So this,
If the Danforth Center gave it to us, I mean, they're doing work in plant research for drought resistance, disease resistance.
so
Not
thi-
everything they do is evil.
Not everything.
another thought, if we want more marketing, is to basically piggyback on something like the supercomputing conference or something. If we want to get more of the
Right.
idea that Perl is serious about this, unless supercomputing is in St. Louis, then that doesn't really work out, though.
Yeah. But it's a start. I mean, I think it's a start. We got to start somewhere at the conference, and maybe someday we'll have a 6-day crazy scientific Perl, conference. But we got to start somewhere. And it's like I want to,
We started having an annual conference
So-
days, we can all get some sleep.
Yes, Joel.
Yeah.
So I have a few thoughts, which, first of all, let me say that I just went to the first MojoConf in Norway. And one of the big things that caused it to be a success was that there were a lot of people in Norway and in Oslo doing Mojolicious. And I think that started because, there were a few companies out there using it and they've sort of spread the word. I think if we want to do a scientific conference, I think we really ought to center around a place that's already using it. And I don't know who that was suggesting St. Louis, but if you are there and you have some people in the St. Louis area, I think it's more important to be going to a place that will have local people who are doing Perl and science, because they're the ones you can be sure will be there. And then secondly, I was also going to say that I don't know how to completely. I think piggybacking on an already existing conference is a really good idea too. I don't know quite how I was intending to phrase that, but I think that's not having to bootstrap it completely from the ground up is useful.
Right.
Also, everyone who's in the room, if you haven't signed up for the Quantified Onion mailing list, that would really help us know who you are and where you are.
Sure. Looks like.
And that'll help, as a base point for organizing.
Like I was going to say, hello. Like I say, because we're kind of getting towards the end of things. Like say the Quantified Onion is just a discussion group for this. Maybe create an RC channel, but to start the talk to get everybody identified and say maybe someday soon have a scientific Perl workshop. Any other thoughts, questions?
And also,
yes.
One more quick thing about that: if people have science that they want to present, say you go, I don't know what I'm doing in Perl, it's worth talking about. Well, don't tell us about the Perl, tell us about the science, and we'll see the Perl at the side of it. And then we can go out and say, I know someone who's working on, I don't know, bio something or other, and they're using Perl, and you can show that off. So come to a talk like that and talk about your science, and even if Perl's on the periphery of it, it's still useful.
Okay.
Yeah, so just to do a plug for the bioinformatics side of this, the BioPerl project is part of the openbio.org family. So there's BioPerl, BioPython, BioRuby, Bio, all these things. And the 15th annual Bioinformatics Open Source Conference, BOSC 2014, is in Boston, Massachusetts, July 11th through the 12th of this year. So if bioinformatics is your branch of science that you're interested in, then there you go. Science broadly, obviously, is a much larger topic.
Yep. Any other? Yes.
I haven't worked with it in a long time, but I just wanted to plug. There's this toolkit called Cactus Code.
Cactus Code?
It's cactuscode.org.
Okay.
And there's a toolkit called Einstein Toolkit that's actually built using it, and they do astrophysics simulation. And basically, what you do is it's Perl-based. You define your application, and then it'll transform your definition of your application into Fortran or C, and it deals with data types, parallelism, and sorts of things like that.
This?
Yeah.
Okay.
It's pretty interesting. I mean, I'm not vouching for the quality of the code, Perl or anything in there, but it absolutely is driven by Perl, and I think it's a pretty interesting thing. I don't know how often they update it, but yeah.
One other, just thinking about it, there's one other conference we could probably piggyback on pretty easily. YAPC.
Yeah?
Would
Yeah,
people here be willing to come back next year and give a talk on the science you're performing and not the guts of the Perl, but what it is that Perl does for you that makes you want to use Perl for that kind of science? I've been bitching and whining for years that there should be a bioinformatics track at YAPC, and nobody goes out to try and drag in because most bioinformaticians don't think of coming to YAPC. They go to bioinfo.
right.
Well, what I'm saying, so if
Well, it's up to organizers. Like, say, I think Gene Hack, John Anderson, was kind enough, I think, to give me this panel, and then Walt had an obvious good thing too. I mean, just it's getting it started and then pushing it. Yeah.
would people be willing?
Well, that's where I think having scientific talks might also help. Sometimes people don't want to talk about tools.
What was that? Was that Joel?
If if you also get people talking about their science, not just their tools, they might get more enthusiastic to talk about it, and you'll see the Perl shine through there. But
Yep.
if you're just talking about what scientific tools do I use, you might not get as many people submit talks.
Right.
But then if there were a track called, Quantum Perl or Perl and Science or something at the next YAPC, and we need enough people willing to stand up here and describe their work and fill at least a day, otherwise it isn't a track.
Right.
Or 3 days if we really did it right.
Mm-hmm.
Would people be willing to do that and actually submit talks and say, I'm submitting this talk for a track on science? Yes or no? Raise your hands. I would.
I would wrangle them. I mean, I don't do it. I mean, I'm just support. Hey, get Joel. I mean, guys, I know Joel and Dave.
I mean, we're not actually using Perl at my office now.
But we get to steal your ideas.
We can steal
That,
ideas.
that's the point of what Python,
About
Perl.
science, not just about Perl. That would people be willing to come in and say, this is the science I'm doing. These are the tools I'd like to see. Forget what language they're in. This is what I am doing.
Yeah.
Because that's the first part of the discussion, is find out what people do. Because then we can start identifying what needs can we fill.
The pain points, the strengths, the weaknesses. Yeah.
I was just going to say, for me, I don't do science anymore, although I'm interested and highly interested still in HPC and scientific computer, and especially Perl. So, I'm interested in discussions in general.
Yeah.
Yes.
Well,
Yeah.
would you be willing to present something on HPC and Perl? Fine.
There we go. We got one talker. Yay! Do I have two? Do I have two? Do I have two? Yes.
I described W curves, but the point is, if people are willing to come in and start talking, that's where we get the ideas that eventually end up in the code.
Right.
But we're not going to have code unless people are willing to discuss the science and what they need to get done.
Cool.
There were already a number of talks. I wish I had gone to. I was at some others, but it was on thread pools and some like.
Right. Those are those wrenches and guts and tools.
And guts stuff that I wasn't aware of this. I mean, they're typically I think being used to drive websites more than
Right.
But because we don't know about it if we're not in that world.
Right. Well, I mean, it's a.
Wasn't that just for CGI?
Oh, really? Oh, wow.
So,
CGI.
yeah. I guess
That would
we're.
be the goal, is to track at the
I
next
guess we'll
YAPC.
go over. I don't know. Let's keep going. Any other questions or comments? Because we're past time now. So, if not, all right. Thank Joe Berger, Jay Hanna, Dan Jacobson, and Walt Mankowski. Kind enough to fire questions at them. So, thank you.
Thanks a lot.
Thanks, Joel. See you around.